To find percent composition, you take the mass of the element you need of 1 mole of the compound divided by the mass of the entire compound. Of course, you look at the periodic table to get that information. This was examples that you saw on the front page. On the second page, it says, verify that in C4H10, the percent composition of carbon is approximately 82.6%. And it tells us to use these values, 12.0 grams per mole for carbon and 1.01 grams per mole for hydrogen. So we know that carbon, since we want to know carbon, we know 4 times 12 is 48. So we have 48 grams per mole of carbon divided by, we now have to add, it says 1.01 grams times 10. So with a calculator, not that I need one, but 1.01 times 10 atoms of hydrogen gives me 10.1. And then I add that to 48 to get 58.1 grams per mole of the entire compound of C4H10, which is butane. Now, what I'm going to do then is take 48 divided by 58.1, and I get 0.826. I have to times that by 100%, and I get 82.616179, but 3 significant figures is 82.6. So we're going to round to 3 significant figures. So I get 82.6%. Now it says to calculate the percent composition of sodium in sodium sulfide. So on the periodic table, sodium is 22.99. And what we'll do is we will use 22.99 is sodium. So I know I have 2 times 22.99 is, and again, if we just use our calculator, 22.99, I get 45.98, and that's grams of sodium. And so we know we're trying to find sodium, so I'm going to say 45.98 grams per mole of sodium. And again, we're doing 1 mole, so I don't necessarily have to say that. Sulfur, we know, is 32.07. If I add 32.07 to 45.98, plus 32.07, I get 78.05. And that is what I'm going to divide this by. And again, we don't have to do grams per mole because we're assuming 1 mole, so we could probably just say grams on all of these. But the grams, so we have 45.98 divided by 78.05, and I get 0.589. I times that by 100%. And I get 58.9%. And actually, I did 4 significant figures in this problem, so I'll leave it as 4 significant figures. Now in this problem, they have some of it figured out. The structural formula is kind of just for fun. We're not going to ask you to figure out structural formulas. If I have hexene, if the percent composition of hydrogen is 14.4, I can actually just subtract it from 100. 100 minus 14.4 is going to give me 85.6%. And I like to say percent, even though they didn't put that there. In this one, if I count the carbons, I see 1, 2, 3 carbons. and I see 1, 2, 3, 4, 5, 6 hydrogens. So the molecular formula is C3H6. The percent composition, notice it is going to be the same ratio as the one above us. So I'm not even going to do the math. I'm just going to say it's going to be the same. All right. This is C6H6. That's benzene, the one I was talking about the other day. And we know that carbon, it's going to be a 1-to-1 ratio. So I know that the percent composition of hydrogen is going to be approximately, I'm going to put it over here, 1.01 divided by, sorry, I'll say 13.02. 1.01 divided by 13.02, and I get 0.07757. So times 100%, I'm going to just round this to 3 significant figures and say 7.76%. I subtract that from 100, and I'm going to get 92.24%. Cyclobutadiene, what we're going to do is figure out how many carbons. I count 4 carbons. So the subscript is 4, and I found 1, 2, 3, 4 hydrogens. Sorry. So the ratio is exactly the same as here. Notice they actually told us it's 7.8% because they again rounded it to the nearest decimal, to 2 significant figures. All right. But it's going to be exactly the same because it's a 1-to-1 ratio. And that's because the empirical formula, which we talked about, is going to be CH. The empirical formula for these two is going to be CH2. Here, this one, I have 1, 2, 3, 4, 5, 6 carbons, and I have 1, 2, 3, 4, 5, 6 hydrogens. Notice here, I have the same molecular formula, but I don't have the same structural formula. Again, this will be 7.6% and 92.24%. Now it says verify that the percent composition of carbon and hydrogen for hexene in table 1 are correct. And I'm going to just say we did that because we could take 6 times 12 plus 12 times 1.01. If I do that, 6 times 12.01 gives us 72.06. And then I have 12 times 1.01 gives me 12.12. And I add that together. Sorry, and I get 84.18. And I will do the top one. So if I take 12.12, 12.12, and I divide it by 84.18, I get, times it by 100%, I get 14.4% to the nearest 3 significant figures. And of course, I subtract from 100, I will get the same. So we did this, we filled in the blanks already. Can you determine the structural formula? No, not usually. I'll say not always. All right, notice that benzene and 1,5-hexadiene have the same molecular formula, but different structure. So, not always. What is true about the percent composition of two different compounds that share the same ratio? They're going to be, if they same the share ratio, which again the same, they have the same percent composition. That's the end of page 2.